Hello guys, this is CodeNCode and this is second lecture of Java design patterns. Right? In this lecture we are going to cover another one of the creational design patterns, that is builder's pattern. So let's have a look at what the builder's pattern is, why do we need it at all, and how to implement it. Right? So the builder's pattern. So a pattern is a creational design pattern that lets you construct complex objects step by step. So as again, this is one of the creational design pattern. That means it allows you to create an object, right? And how does it do it? It allows you to create complex objects step by step. We'll see. We'll see how this helps, right? And this patterns allows you to produce different types of representation of an object using the same construction code. So we have the same construction code using which we can create different types of representation for same class. What does this line mean? I'll explain in the next slide, right? So let's say you have a house class, right, in which you have um, multiple fields, right? And when you set different fields, it results into different representation of that class, right, that object. So for example, you have a house, and when you set the garage field, you have a house with garage, and you set the swimming pool field, so you have house with swimming pool. Same goes with garden and fancy statues, right? So first thing, a simple class, you can have multiple representation of it. So since a house is nothing but a class, right, and it has multiple fields like garage, swimming pool, fences, statues, garden, so on and so forth. There can be other fields also, right? So when you set different fields, it results in different representation of this class. How can you solve this? How can you basically provide a way to set different values, right? Seems like a very like simple problem, and indeed it is. The problem is not the complexity of setting the values, but how it impacts your code cleanliness, right? Readability, things like that, which we target in design patterns, right? So how can we do that? Provide different ways to set different values. One of the ways you can do is provide a constructor with all of the values. So I have a house constructor of it, and then there are multiple fields, and I can jam it all in this constructor, right? Number of windows, doors, rooms, garage, swimming pools, statues, gardens, and some other fields also. One of the solution is to, provide a constructor with all of the fields. This way, we can set the fields we want to. Yeah, this is one of the solution, right? But if we do that, you see, the code doesn't look very good. If I'm trying to create an object, a simple house object, right, where I don't want anything like garage, swimming pools, statues, or any other things, this is how the construction would look like. For the rest of the values, I need to pass null. Clearly, this doesn't look good, right? Similarly, if I want a house with a garden, I can provide the value of a garden, right? Rest of the values, I again have to set null, and the important ones like windows, door, and rooms, I'll pass that. The rest of the fields are again null. So when you write this kind of code in production, this doesn't look very good, right? Where's the cleanliness of the code, right? Where's the readability? So this doesn't look very good. So clearly, providing a constructor with a lot of fields doesn't make sense, right? It's not the best solution. So how can we do that? Let's have a look at some of the solution, then we'll move on to the builder's pattern. I'm basically setting up the tone that why do we need builder's pattern at all. One of the solution you can do is by constructor overloading, right? For different scenarios, for different combination of the fields, you can provide different constructors, right? So a simple house, you can provide a constructor of that. Another constructor you can provide with for house with garage, another constructor you can provide with for house with garden, so on and so forth. You can provide different constructor for different combination of the fields, right? And this way, earlier a house with garden that we had to define like this, what we can do, we can uh, you know uh, bring it down to this initialization of the object, right, where we are only passing the essential values because we have a constructor for that, because we are using constructor overloading, right? So the earlier code which was looking ugly now looks much better, right? Now, the problem with this approach is, if you have a lot of fields, there will be a lot of combinations. If there are a lot of combination, you will go ahead with a lot of overloaded constructor, right? And that would make the actual class look too ugly, not so clean, right? So clearly this is not the best solution we can come up with. So one of the other solution you can try is using the setters, right? So you can define a basic constructor, right? And then you can provide the setters for different fields. Now, if you wanted to define, this is how we were defining the house with garden earlier, right? The object where we had to pass null fields, right? If you have the constructor, the same object initialization would look something like this. You can define a house and then set only those fields which you require, right? Windows, doors, rooms, and a garden. Now you have a house with garden, right? And this code is much cleaner, and you can see, oh, my bad. You can see the original class is also not polluted, right, with boilerplate code. Now, the issue with this, I mean, this looks good, no doubt, looks good, but again, this has a problem, and one of which, the important one, is that immutable class. This solution doesn't work with the immutable class. So, immutable classes are those for which once you have initialized an object, you don't want its properties to change, right? But since you are providing a constructor, sorry, a setter, you once you have defined an object and you have the setters, you can change the value of that object, right, which we don't want. So this solution doesn't work with immutable classes, where once you have the object, you don't want its properties to change, right? Right. So it doesn't work with immutable class, and the code is not as cleaner as builder pattern can provide you, right? Because if you see here, each time you have to set a field, you are calling, you have to write the object name, right? Object name dot set windows, object name dot set doors, so on and so forth. It could be cleaner if it provides a way to, change the methods. If it provides method chaining, that means you can call one method after another. It would have looked much cleaner, and that is exactly what builder's pattern provides. So let's have a look at the different solution that we have gone through and what builder pattern provides, right? So multiple constructor solution we have gone through doesn't make sense. We don't have to go for multiple constructor, right? And this doesn't work. We have seen that. And setter solution doesn't work with immutable classes, but pattern provides you a solution with also works with immutable classes. And also builder pattern provides you method chaining. That means you can call one method after another, which makes the code look much cleaner, right? So yeah, this is what builder patterns provides. Now the question is, how do we implement builder pattern? Let's have a look at that also. All right, so let's have a look at the implementation of builder's pattern, right? So let's say I have a class car for which I want to implement the builder's pattern, right? So what I'll do, I'll go to the, let's have a look at the cars class first. So it has two fields, right? Number of seats and engine. It is of type engine. Engine is basically any num that I have defined. It could be diesel engine, petrol engine, hybrid engine, whatever, right? So these are the specific types of uh, engine that could be there. So I've defined an enum. So a class car has engine and number of seats, right? So first of all, keep in mind that since we want builder to create the object, first thing you will do is make the constructor private, so it couldn't be called from outside, and there's you can't directly initialize the object of this class, right? So make sure the constructor is private. What is here, I'll explain in a moment, right? So when you're going to create you are going to provide builder's pattern to initialize the object of it. What you will do, you'll first define a static class builder, right? And then in that builder you can have the same number of fields which you have in the original class, right? So number of seats and engine, right? And now you can only set the fields through the builder class itself. So that is why inside the builder class, what you'll do, you'll provide the setters, right? So you see, set number of seats, so setter for number of seats, set engine, setter for engine, right? So first of all, make the constructor private of the original class, create an inner static class builder that is responsible for initializing the object, And since it initializes the object, it should have the same number and exact field as the original class. And this builder will have the setter functions, right? Usually, you might have seen here, usually the setter functions are setter function usually return null, right? But here we are returning the builder object itself. Why? So that we can implement the method chaining, right? Since all of the setters are inside builder, right? So if you return builder from it after calling one function, you get the builder object. Then you can call another function on that again, and that provides you with the functionality of method chaining. That means you can call one method after another without having to write the object name again and again, right? So what you'll do, as you can see, these are simple setter functions. Only thing is that you are returning the builder from the function after setting its value, so that you can call the method again and again. Basically, you can apply method chaining. So what you will do, you will define in a static class builder, have the same set of fields as the original class, provide the setters which return the builder itself, and finally, since it's the responsibility of the builder to build a car object or whatever class you are defining it for, there must be a build function in which what it does, it builds that object of that um, class and returns it, right? So from here you are calling the constructor of this class, and since this constructor is private, it couldn't be called from the outside, but you can call it from the builder because builder is the inner class. So you can call the constructor from here. So you see, in this constructor you are passing the builder object. Since in the constructor you got the builder object, you got all of the fields that are required for you to set, right? And from the builder object you can set the fields. Done, right? Once you have set the field, you have an object of class and you are returning it from the build function, right? As simple as that, right? So if you have a look at the use case of it, I'm defining a car object using the builder of the car, right? So car class dot builder, you can directly access it because this is a static class, static inner class, and then get the new instance. I want the instance of the builder so that I can set the fields. So if you see in the in the car class, I have defined a new instance function that returns a builder using which I can set the values, right? So I'm getting the new instance. After that, I can set the values. So you see here, this is what I was talking about, the method chaining. I'm calling one method after another without having to write the object again and again, right? So I'm calling the builder and getting the new instance. After that, once I have the builder instance, I can set the engine, I can set the number of seats, and then I can call the build function. And build function is the final step which creates the actual object of car class, sorry, of class car. Once you call the build function, you have the car object and you can do whatever you want with it, right? So I'm just printing it. So if you have a look at it, I have overridden the toString method for car class, and I'm basically printing the engine and the number of seats. So if you run this example, you'll get to see the code in action, right? You see, car engine is diesel engine and number of seats are 12. Let's change it. Instead of diesel engine, let's go for a hybrid engine, and number of seats, let's bring it down to 2. Run it again. Simple example, right? Run it again, and then we have car engine hybrid and number of seats 2. So you see, builder pattern provides you a clean and neat and clean way to initialize the object using the method chaining and the setters. And again, it works with immutable classes because the original class doesn't provide any setters. All of the fields are private, and final, once you set them, the value are not going to change, right? So this is basically implementation of builder's pattern in the immutable class, right? So yeah, this is how builder pattern works. Hopefully you are able to get how this works, and you'll be able to implement the same with any other class. And I highly recommend you that create a basic class and then try to implement a builder's pattern yourself, right? So yeah, this is it for this lecture. Thanks you guys for watching, and till the next video drops, keep coding. Thank you.